My name is Mike Lavarius, Assistant Director for Data Analytics and BI for the Fulton School of Engineering, Academic and Student Affairs Department, Data Team. There's a whole lot there, so you don't have to remember all that. There's a QR code if you want to link to me and my LinkedIn profile. I'll have it up again at the end. And just for some housekeeping, if you are able to fill out the form here for attendance, that would be great. I'll leave it up here for a little bit. But what I'm going to go over here today, first off, is just a general introduction about myself, Mike Lavarius. Uh, I'm a new to ASU for the role of the assistant director for the data analytics, but I'm not new to data. In my background, I've come from a lot of different industries. I think a lot of people here know that data is something that can translate to any industry, but high level, the concepts can go anywhere. You don't have to be within a specific industry to be successful. One of the things that I do want to go over is what it will take to be successful from a data analytics standpoint or a data analyst standpoint. I'm not going to try to talk too much to my PowerPoint just because being in the Army, they killed us through death by PowerPoint. And a lot of the soldiers would keep awake by trying to sniff their hand sanitizer. So hopefully no one has hand sanitizer here or will have the need for that. Uh, just a little bit more background too is this is a little bit of a selfish reason why I'm doing this because as a leader, as a hiring manager, I've interviewed and I've hired a lot of data analysts in my career. And one of the shortcomings that I've seen with newer data analysts is that while they are, coming out with these certifications and the training, there's a key fundamental skill set that is missing from a lot of data analysts, and it becomes apparent once they're in their job and they basically hit their first roadblock, which is the data. And well, pretty important if you're a data analyst. So this is to kind of help bring awareness and address this concern. Is that we'll first start off with what's a data analyst? Well, here it is. In a nutshell, you're collecting information, processes, interpreting the data, using the different tools at your disposal, Power BI, Tableau, Excel. Everyone loves Excel. It's going to be around forever. I think it's never going to die. It's because everyone loves export to Excel, regardless of whether you're producing a dashboard through Tableau or Power BI. Most used feature is going to be export, right? So, again, various industries. But what most data analysts really what it all comes down to is you're taking a data set and you're transforming it into a chart. You're producing something that makes this wall of figures, all this information a little bit more readable, a little bit more consumable. But what happens when you hit a roadblock of the data and you don't know what you're producing if it's accurate, or um, you don't know where the information is coming from? So that's one of the key things that I want to address here is what happens when you hit that roadblock. So pulling this from Joey's presentation, he talked about these different career paths. In order to, in my opinion, evolve into the next levels from being a data analyst, it's going to be data modeling, or at least understanding the conceptual properties of your data, relational properties. So if you want to be a data scientist or data engineer, you're going down a technical path and you're going to invest time in that. But understanding the data is also necessary from a business analyst standpoint, because as a business analyst, you should be able to be a translator between the technical side of the team versus your end users. So your stakeholders, requesters out there. In order to understand that better, you have to understand data models. So why are data models important? Well, they help organize and structure your data. And two main concepts of data modeling are Snowflake and star schema. So obviously with a star, there's your star schema. And Snowflake, it's a little bit more complicated. I'm not going to go too much into it, but basically with a star schema, you're looking at having one centralized table that has your aggregates and having your details, customer name, address, location, things of that nature. What's really important here isn't so much the data here, but its relationship to each other. So how do you know that the data that you're being presented to turn into a chart or table or bar graph is accurate? You don't really know unless you understand the underlying data beneath it, right? Know the relationships. Well, if I have a table that has student data and classes, how do those two relate together? You know, am I connecting them via a student ID, course ID, or some other method? And the relationship between those two, we talked about cardinality. Is it a one-to-one relationship? Is it a one-to-many relationship? Or is it a many-to-many? Because then that's going to impact what you have in terms of your results for the data set. Are you getting one-to-one? Are you getting dupes? Are you getting so many records that you can't fit it into your database or data table? So understanding the underlying data and how it relates is the reason why data models are important, because before even writing a single line of SQL code or anything else, you can do this type of analysis without writing, you know, any type of code. You can pull up your database, you can pull up your Excel file and look at the fields. I think Josh Johnson yesterday covered data exploration as part of that. A data exploration, you don't need a single line of code. If you pull up your data, you can take a look at it and just see like what are the relatable fields. Understand if you're going from student data to class data to program data, how do you connect it all? Because that then becomes the foundation for the type of code you will write. If you understand the relationships, you'll know what to use for your inner joins, your right joins. Um, Snowflake schema works a little bit differently, but gets a little bit more detailed. You still have your facts table, but then you have your dimensional tables upon dimensional tables. And usually with Snowflake schemas, what you're trying to do is you're trying to limit the processing by using IDs. So you'll have description tables that will have codes associated to your details. And then another table, it'll just have the IDs so that once you bring it into your facts table, you just have a whole bunch of numbers. Now, if you're just presented with a sales facts table with a whole bunch of keys and you don't understand the relationships, then you don't know what tables are being used or what's being pulled. So that's why data models are extremely important. That aspect is it just helps you to understand the relationships. So from a conceptual aspect, none of this really requires you writing any type of code. It's just looking at your data, understanding it. Now, there's a lot of ways to practice, but there's some good sources out there for this. I mean, if you have access to your database sources, you can play around with it. There's Kaggle.com, Maven Analytics Playground. They have a lot of free data sets, but here, just this data set that I used ChatGPT to produce a data set, a quick data set. All I did was input and said, give me a data set with student data and class data, 10 columns with 50 records. And this is what it spit out for me. And so you can see, if I did this separately, if I said, just give me a student table and give me a class table, that makes my two fields, my two tables that I'm playing with. And from there, I can practice and play around with creating relationships. So, you know, with the theme of AI at this conference, as data analysts, you have resources available to you, but you can make your own to practice these concepts. And so you can see here, like if I wanted to do a study of how many students go to a specific class, well, my relationships are going to be based off of student ID and class ID. If I were to break this out into a separate class table and student table, in my class table, I'd probably have class ID, but what I would also have is another student ID column, because then the relationship or where I would make my join in SQL or any other place would be my student column would be student ID with a join on student ID in the class table. So again, very high level, but the concept is I understand what my relationship is between the two tables. Now you extrapolate that out to other tables like financial data, student aid data, or financial aid data. What else do we have? Enrollment. Our team uses a lot of enrollment. What else do we have? Research. Yep. So again, a lot of complex data systems out there, a lot of complex tables out there, but how do you know something is wrong or something is accurate? It's part of the validation, but in order to evolve yourself, as a data analyst and to improve, this is a primary concept that I think is missing from a lot of data analysts that I think, you really want to work on, which is expanding on the relationships. From a strategic point of view, this is kind of an expansion of that, but here's some applications for it. So when we're looking at the architecture of something and we want to, it's kind of hard to see, but basically what you have here is data governance group, business intelligence and analytics, and an IT data engineering group. Well, you have all this data, you have all these relationships, but what is the best way to scale out? Well, there's a lot of definitions, a lot of things out there, and so it's good to have a governing body or group that collaborates with all the different areas that is driven by the business or stakeholder side. So that's why I say, as a data analyst, and you want to evolve your career into like a business analyst, data modeling is a key skill to have to be able to communicate with this group over here, with your business areas, because they're the ones with all the business knowledge, all the business logic, all the business content, right? All the things that the data doesn't contain. But what it does is once you build a data model with the logic supplied by the business, then you're able to build these data sets. So what you have here is a finance data set, sales and marketing, clinical member data, or clinical and then member data here. And then you have a governance group and data engineering. So it's a confederated or federated, I guess, group that helps to govern an institution so that everyone is pulling from the same playbook. When we say faculty here, how many different definitions of faculty do we have? When we say enrollment, what do we mean by enrollment? When we talk about new enrolled students, what's that definition? If we go to College of Engineering and compare that to the Carey School and the Teachers College, right? They may be aligned or they may not be based off of the business logic. So that's where the data governance group helps align that, because at an enterprise level, if we build that into a data model that says new students is this definition, we build that logic in, whether engineering is pulling that number, whether Teachers College is pulling that number, we have the same number. Then if there's any issues with, is that number accurate? Well, now it's not a college to college difference, it's an institution level difference. And then it becomes a discussion at that level to say, well, how do we want to define that? So Again, helps bring validation and clarity to your data, because how do you know something is bad if from the engineering college, we're saying enrollment from an ASU level, institution level is this number, but Cary School is saying something different. We're like, well, you know, we use this logic. Well, we use this logic. Are they wrong? No, they're different, but they could possibly be wrong. Why don't we align ourselves? That's where we have the discussion of, well, what are we going to market out there? That's where the importance is, right? The impact to the business is, student enrollment data that goes out to the public, that goes out to news, and so usually that's approved by the provost institutional analysis area, and that's the definition that they're using. But if we're pulling different numbers than they are, then we have to align on it. And again, how do we know that our data is the same or different? It's having the skill set of being able to data model. So the other part for strategic thinking or strategic application is also architecture, but in a sense that having some consistency from governance wise, but also across the board here. So once you have certain data models here, you can build data marts for specific groups. So you have an operational data mart, member data, sales data, HR data, and finance data. But the great thing about this is if you have a certain architecture where you're keeping considerations in mind about relational joins in your architecture, you can then develop more robust, more complex models that adjust different needs. So you can combine operational data with member data by having the relationships of, well, certain departments in my operational data oversee the member data. So when I'm building out my architecture for member data, I need to make sure that I have to have an element of which department ID, manages that. And by doing so, if I have something similar with HR data of, let's call it employee IDs, and we want to be able to get cost of care or how much, what's the return per person, right? Then we can build a combination of operational, member, and HR data that then supports operational performance metrics. So something similar here, you can do sales data, finance, and HR, and then you have business operations. And then, since we're talking about AI and machine learning, you can have a specific data set that does analysis, that combines member, sales, and finance, and that can be used for data science or machine learning models. So, without data modeling or the concepts of it, it's hard to get to these types of end products. You may just be stuck here with just specific data for your area. But if we want to share information, if we want to work with information from other areas, an enterprise level model relationship is important. And again, all that foundation comes down to data modeling at the very basic. So understanding relationships, we have a whole lot of data out there, but how it's organized, how it's structured, and how it relates to each other really is important to understand what we can do with it from not just a singular standpoint, but from a expanded enterprise level standpoint, and not just here at ASU, but any industry really. All right, a little bit faster. So, how many people here are data analysts, aspiring data analysts? How many have a foundation or a background doing data modeling? All right, so a little less hands. And that's one of the things that I want to be able to address is that because you have the ones that don't have that experience, Megan, you don't need to respond. um, is that just because you haven't been presented with that type of work, or it's just that work just doesn't come around, or it's not important in your roles? Okay. And why would you like to have that information? Okay. What are some strategies that data analysts in here use when you have hit a roadblock and you don't know maybe the source of the data, or you don't know if something is accurate? Yeah. Anyone want to share? Okay, Megan.
I think it kind of depends on the type of data that I'm working with. Because I am heavily in financial data, and work extensively with the Workday data. Here. I will frequently go to, when I have something that I pulled out of the warehouse, or some data set that I'm looking at, and I'm trying to validate it or figure out how things integrate or don't, I will go to the source system and look up a couple of examples. I put this in one of the Slack channels recently, and someone was asking about a table in there that's an aggregate table. And they were asking about like some of the data fields that are there. And I said, I always, when I'm looking at HR data, use myself as an example, because I know I can, and Josh Johnson will say the same thing about this. So you go out and you pull a couple of pieces that you know how they should function, to make sure that what you're seeing in the data that we have is functioning the way it should.
So one of the things Megan brought up too is important is like the data that you're looking at most likely is at an aggregate level, a certain level where you've got some counts or something that you're accessing through an enriched layer. But how do you know if that enriched layer is accurate? Well, hopefully there's enough processes in place that that data has been vetted. But what happens if you need data at a lower granularity than what that enriched layer presents you, right? Then you have to understand, okay, well, what is the relationship that is producing these aggregates at this level? You then have to go and find out who is the owner of the data, or try to understand where the lower level granularity data is, which is, like sometimes your bronze layer, your just, above source level. And once you get down to that level, then you have to understand or reverse engineer what that enriched layer was, or come up with your own logic through data modeling to get to the type of data that you need using the lower level granularity data. So again, like the importance of data modeling is that it helps you understand data, it helps you understand your limitations of the data that you have, and just being presented with a data set or data table to build into a dashboard or a report, while all that's well and good, you're building something nice and fancy. But if that data is, let's call it bad, I go with the concept crap in, crap out, your dashboard is going to be, displaying crap data. Or in this case, there's a difference of research expenditure, $30 million difference from source data and some other data that's produced out there. So to understand that $30 million difference, what are those steps? And, that's part of the investigation process. The exploration process is, okay, well, where did this number come from? How was that produced? And yeah, it takes a little bit more time. It takes a little bit more effort, but as part of the exploration, as part of the validation portion of it, it gives you a better understanding. And, just like what Joey was saying earlier and everyone else, is that you're always learning something new the more exploration that you're doing with the data, right? And then you become more knowledgeable about it. Then you can start to expand into the other areas of data science, data engineering, or if you're not looking to invest in your technical background, maybe you're looking to invest in your communication skills or project management, the business analyst side. But you use that knowledge to expand your foundation. No. Any other questions? Or I had questions, but any questions from anyone else? Anyone want to share their experience coming in as a data analyst? What they wish they knew and did not know? I'm gonna have to call Megan again. If that's the case, because she's on my team. And what about you?
I work as the data analyst for learning exercise, and my day-to-day will include both like analyzing the data, but at the same time designing these complex data pipelines, integrate data sources. So yeah, one thing that I want to highlight, as you mentioned, like if I am just using the aggregated data, I am kind of limiting myself. Like I don't know in what deeper investigation I can dive into just to support my learners. Like if I'm getting just how many learners are passing the course, how many learners have completed the course, then I'm limiting myself to see how their grade distribution looks like, what groups or what classification I can have for those learners, and what learners need more help in order to boost their efficiency or boost their knowledge. So yeah,
Yeah.
like, I guess data modeling is a part where which plays a vital role in terms for data analysis.
So that's a good point there too, is being able to break down the aggregate data or being able to pull more analysis out of it is that since a lot of the data that you're probably pulling and developing into a dashboard, it's descriptive. It's descriptive analytics, meaning you're just pulling the data, you're sending it back to the requester, and there it is, right? You're not doing anything to it, really. There's no transformations, and you're not providing any type of real analysis or insights to it, right? That's where I think a lot of people in this institution are. Is it's just there's a lot of data requests and push it out. Where BI teams, data teams want to be able to evolve to is the predictive and prescriptive, or being able to provide the insights. And that's where the ROI comes in for the data teams, right? Is, I hate to say it, but anyone should be can pull data, right, with a certain level. And they get their information. But having the business context, being able to understand the sources, being able to understand the limitations of the data and its sources, then gives you that additional, dimension that you can provide as analysis and insights. Because then you can say, this data is only 97% accurate because we have this limitation. It was hand entered, it was, not a drop down field, open text, and there is no relationship to the course data because there is no direct field between students and courses. And so with that, you're making your own set of relations and flags in order to create those joins. And when you're doing that, there's certain margin of error that you're gonna produce. So it becomes, again, just another tool for helping you understand, like, what level of service am I providing to the requester. I think where we all want to be able to get to is move away from just descriptive and move over to prescriptive and predictive, where descriptive can be handled in a self-service or self-support manner. 80%, if you build a data model that covers 80% of the requests that you get in, then the remaining 20%, you have that 20% of time available to spend on deeper dive research, being able to understand the data better and adjust those in a lot more detail than you would if you're sifting through daily requests of, I need data of counts of enrollment, or I need data counts of admissions, right? Like those simpler types of requests, as can be handled by a very well-defined data model, based off of your research of past requests. You build that out, then you can, reduce the workload and the backlog that you have. Then you can focus on your, your more complex stuff. So the whole point to this is that, models are not just for the supermodels. Anyone can be a super data modeler. It's just, what are you willing to do for it in terms of where you're trying to invest the time? How do you want to evolve? And from my experience and my opinion is that if you're a data analyst now and you don't have the experience in data modeling, that's a key key skill set that you should develop so that you can, further evolve your career and, further impact and provide return for your different support areas. So thank you very much. If you like to please fill out the survey or connect, well, I have my links here. Thank you.